Okay. All right, properties of exponents. There are 7 of them. This will probably be the lesson where you will watch and you'll say, ooh, yes, this is easy.
And then
when I ask you to put them all together, you'll go, wait. This is the hardest thing I've ever done. So it's really not, you just have to follow the rules. And remember that they're rules. There are not orders of operations with these like there are. By the way, did somebody leave their pencil pouch in here? Easiest way to approach this is for me just to give you the properties and then we'll apply the properties. This is 2.1. Yes, we are in chapter 2. I do not make you remember the names of the properties. I find that very irrelevant. As long as you know the properties themselves, I think you'll be okay. All right. You're welcome, Donovan. Let me show you the first one. First one. Yes. And scientific notation. Woo! Okay. The first one. I don't know. I get their names mixed up. Okay, so let me see. Product of powers. Again, you don't have to memorize the names. You just have to know what they do. Product of powers. So, product of powers says I'm multiplying these two things together. X to the third times x to the second. Okay? Notice that the base is the same, and that's the key. The base must be the same. So somewhere on here you might want to put a note. Base must be the same. So if this was x to the third times y to the second, this rule wouldn't apply. Okay, but because the bases are the same, it does. When you multiply and you have the same base, what do you think you do with the exponents? Add them together. Okay. Yeah. So this would give me x to the fifth. So if the bases are the same, then you add the exponents because I am multiplying. Right? All right. Yes, no, maybe so? Tell me. You're so smart. That's actually the next one I was going to do. So she said, let me take a guess. When you're dividing, so if multiplying is product, and then I'm going to call this one quotient of powers. So this time, again, same base. It's important. Same base. X to the fifth, over x to the third. So, let me guess, if you add when you multiply, then when you divide, you probably subtract. So this would give me x squared. Yes, ma'am. No.
Is it called quotient? That's what you get. That's what it's called. And then that's what
Can it stay the simple?
How many of these are there?
7.
This is like your classic 3.
All right, let's do another. By the way, let me show you an example now that we've done 2 of how we might put two properties together. If I had x5 y2 over x times x3 times y.
Yeah.
So yes, on the bottom, notice that I do have a product of powers.
So would it just be
XY.
So I got x5 y2 over x4 y, and now I can subtract. So I'm showing you this because if I start mixing these bases up, I want you to see what happens.
You just do it.
Right. And so 5 minus 4 and 2 minus 1. And it doesn't matter, there's not an order of operations with these. In other words, if I had done 5 minus 1 and taken care of these two first, so 5 minus 1 is 4. So I did these two, so x3 is still on the bottom and y. I still come back to the same thing whenever I subtract. Right. So it's not like, oh my gosh, you combine the bottoms first and then you subtracted. You won't get the same thing because you will. You'll come back to the same way. In other words, as long as you follow valid properties when you do it. That's the key. Okay. Y'all tracking with me so far? Yeah. Okay. Property number, what number are we on?
3.
Okay, we've done product of powers. We've done quotient of powers. Let's do power of powers.
Ooh.
It is. So this is whenever I have something that already has an exponent on it, and I raise it again. It's pretty powerful stuff, an exponent to another exponent.
Yeah.
So what do you do?
Multiply them together.
You multiply them together.
So x, what was that?
Everybody gets the power of a power and the product of a power mixed up because you start getting confused on when you add and when you multiply. Okay. So when you raise a power to another power, you multiply. Let's see. We did we did product of a power, so let's do power of a product. Okay? See why the names are just kind of, you're like, oh my gosh. Okay, so here's the thing. If I've got 2 values or 2 variables or 2 whatever it is, and I'll even put an actual number in there. We did product of power, and this is power of product. That's why it's not really important that you memorize the names as long as you know what it is you do when you do it. So I've got this product. I've got something being multiplied together, and I'm going to raise that to a power. Okay? Now, you absolutely do distribute it through. And I'm hesitant to say this because, you know, if this was a plus in the middle, I couldn't do that, right?
Correct.
Because that would tell me, if this was 2 plus x, that would say to you 2 plus x and 2 plus x and 2 plus 5 times, right? But because I'm multiplying inside, it makes it a little different. I can distribute through. But only because I'm multiplying and not adding or subtracting. So 2 to the 5th, x to the 5th. So if you want to simplify, was that 32? Does that make sense? Because I'm multiplying, I can distribute that exponent through. Okay, that's product of a power, quotient of a power, power of a power, power of a product, power of a quotient. Let's do next. Okay. What? Yes. It's actually the next one. Power of a quotient. A quotient means I am doing what? Dividing. Okay, let's do x over 3. And I'm raising that division problem to an exponent. Again, just like multiplication, distribute. What if, let me just say that, what if this one already had an exponent on it? You would multiply. It's a power of a power. So I would get x to the 8 over 3 squared, which is 9. So power of a quotient, I still distribute. Just be very careful as you're distributing this, and remember pluses or minuses, you cannot distribute exponents inside.
The extra. Alright, now I got it.
Got it? All right. Two more.
Okay.
scientific notation.
It's not getting bad.
And I got to do several examples with you. I told you we were going to fly through the properties. Y'all going to go, oh yeah, that's easy.
Are we gonna work with this property, like all these for
We'll work with it today. We may end up having to work with it tomorrow. We'll see.
No.
Zero exponent. It's 1. That's exactly right.
Something to the 0 power is 1.
Anything but not 0. Anything but 0. Anything to 0 power is 1. 1 fine. 5 to the 0, 1. X to the 0, as long as it's not 0, 1. Justin to the 0, 1. Anything to the 0, 1. Y'all got it? What about what? Opposite of what? Opposite of X. To the 0 power is still 1.
Negative is still 1. Yes, negative is still 1.
Yes. Even if the base is negative, it's still 1. Anything to the 0 power is 1.
So how about if it was?
1.
So let's say if it's
1.
it's like, if X for 1 to the 4th and then parentheses to the 0, and there's a negative on the outside.
Negative. Well, now then your order of operations is going to take over, because are you saying if it was like this, X 5 0?
Yeah.
Well, what this is saying, because exponents come before multiplication, you would do this, so it's to the 0. This negative outside, this is kind of like when we were doing those quadratics. If it's like this, the negative is really like a -1 being in front. Because these parentheses are here, this would be -1. But if you had this, that's 1. You see the difference?
We are going to have anything.
What first? That one? Sure.
Wait, so
Why? You had it on quadratic.
wait, so the negative outside would be negative.
Yes. If the negative is on the outside, then the negative takes over.
Oh, hang on, let me
It forces
copy
it
this.
negative. Okay.
Uno mas.
Uno mas. Uno mas. All right, so number 7.
the one.
I saved the best for last.
It's the knockout.
Oh, negative. Oh, okay.
Does anyone know what a negative exponent does?
It's decimal.
What?
Is it not? X to the negative 3.
Because I hope it's not
over, wait, no, 1 over X. Oh, that's a fraction.
When an exponent is negative, we don't like to keep them negative. It's not proper to keep them negative. So what we do when we have a negative exponent is we make it positive and we move it.
So
Technically, if I had 2 to the -2, that would be 1 over 2 squared, which is 1/4, which is yes, it's this.
We always move it under 1.
You always move it. I'm talking about it in the form of a fraction. If it's in the top already, because this is like 1. If this started out as 1 over x to the -2, then it would become x squared. Move it wherever it is. Move it. Okay. And we're only moving the negative piece, so you could have multiple pieces. Like if I had x2 y -3 over z4, the only thing that's moving there is what? The y, because it's the only negative. So it goes and becomes x2 over y3 z4. I will caution you also, you will have some. If I have 2x to the -5, what does that become? Close.
2 over
2 over x to the 5th, because the 2 is a piece being multiplied just like these two are multiplied. The 2 is also being multiplied here. It doesn't move with the 5. It doesn't move with the x unless, that's exactly right, unless there are parentheses which would move them both. But then, even still, I would distribute that 5 through because now I've got the power of a product, which would be, I'm getting really excited with this. I need to slow down. I can see it on y'all's face.
Yeah,
1 over 32x to the 5th. So that's the difference in those two. Oh no, we still got scientific notation. You need another page, Jonathan.
No, I know what.
Oh, the 7
Yeah, and
properties.
you're really adding on to this.
We haven't done an example yet either.
Well, we have to know.
I just skip one.
Let's do an example. Y'all ready?
Okay.
We'll start out not quite as hard and we'll move to get a little bit harder.
Hey. No,
Well, the choice is yours. So that's a good question though. Remember I kept saying it doesn't matter what you, there's not an order with simplifying these like there is an order of operation. So some of you may see the same base up top, the two A's being multiplied, and you may want to combine those first. Others of you may see the two B's being divided and want to subtract those. Still others of you may see the negative exponents and go, I gotta get rid of those, move them. It doesn't matter as long as you follow valid properties each time. And I think this is why students struggle with it, because it's like, tell me what to do, but there's not, there's not a step-by-step to do. So we're simplifying this. So y'all tell me, what property jumps out at you first? You move them. Everybody says the negative. Let's do that then.
When you put it,
So this one's going down.
you put the B up top, do you add 2 and 6, or do you?
We will, yeah. No, you're going to add, because it's, yeah. All right, so up top, I have A2. That A negative 3 is gone. I've got B6, and the B2 moved up and became positive. On the bottom,
A3.
A3. Okay. I'm not done. Oh, you did the rest of it. Okay.
A squared.
So what jumps out at you next?
The B.
The B's? Okay. The B's.
B8.
A2, B8, because we add them, right?
Oh, it does. You subtract and get another. And then you put it on the bottom. Oh,
Would it be A?
Yes.
Correct. Would it go on the bottom or top?
If I subtract, I get -1. Ah.
over nothing.
And then now you get over A1.
And then I would move yes.
Okay, so I did it
Right.
right.
Just be A.
Okay.
Now it's simplified. I told you I'd start you easy. Start you pretty
Would you
easy.
take one off and leave the A1 on?
So do you put it over 1?
She's about to
Said
throw
it
us
was
off.
1.
Over A2. This one was over 1. This one, the A was
Oh,
negative,
that's
so I had to
by
move it.
itself.
Yeah.
We can leave that.
Another one? Yeah.
They all
Get back in. I know this is exciting for you.
Flip the hat.
I'm going to work inside first.
Yeah.
And I'm going to have x -6, y 4 over 3x -2y. I still got this -1 outside. I'm going to take my negatives just because this is my thought process, okay? This is how, remember, as long as you're following valid properties, you're good to go. I see the negatives next, so that's what I'm going to do next. I'm going to take this x up. I'm going to take this x down. Remember to treat that 3 as its own piece.
That's where I messed up.
The 3 does not move with the variable that it's multiplied to. It's its own piece there. Okay, so now I'm going to simplify inside. So 2 minus 6 is -4. 4 minus 1 is 3. And somebody asked, every time you subtract, it stays up top. Okay. Now I am going to see another negative.
Wait, I wasn't done up there. Come on.
I thought y'all already done it.
Come on, boys. Yeah, I worked it out.
Continue to simplify. I hope you're with me now. I'm going to move the negative down because, again, that's how my brain works. 3x4. Now I've got this -1, which is going to go to everybody. I'm kind of out of room here. Y -3, 3 -1, x -4. So everybody swaps places, essentially. So I end up with 3x4 over y cubed. And I am done. How do I know I'm done? I look through there and I think about my properties of exponents, and there's not one single property I can still apply to that, which means I can't simplify it any further. Oh, record. Let's say I have, and this is actually one of your homework problems. I won't tell you which one. Y to the 11th over 4z cubed.
What's that?
Y to the 11th over 4z cubed times 8z to the 7th over y squared. What do you do when you multiply fractions? Straight across, right? So I always tell everybody, when you see this, don't let it intimidate you. In fact, when I copy the problem, I generally just come here and say, okay, I'm doing nothing but multiplying. I'm just going to make this one big fraction like that. And I'm going to work from there. Does that make sense? Okay. What pops out at you first? The what? The y's. I hear the y's. Okay, which is the division. So I've got, up top, I've got 8z7, and I've got this y11 and y2, so I need to do what? Subtract. What's it leave me with? Over, so I've used those, 4z to the third. What do you see now? The z's. I've got 7 z's up top and 3 z's in the bottom. How many z's does that leave me where? 4 on the top. Do you see anything else you can do? Yes.
The 4 and the 8, the divided.
I can simplify those just like any other fraction, and I can get 2z4y9. And I'm done. Not so bad. So you say.
It seem hard until I get
It just gets see, yeah, when I get home is when I start frantically. And then you see
Don't
Blizzard,
frantic. Text me.
And then you see Blizzard pop up on your phone.
Are you speaking out today? I love that word. It's like,
I'll be here a little while.
That's good.
how long is a while?
But, well, we're not, I'm going to refresh you on what scientific notation is, but we're really going to be doing multiplying and dividing in scientific notation. So tell me, what is scientific notation?
I just gotta have something.
Taking all the zeros and adding a lot of things. It's like
Yeah. It's a, right, it's a way to write really big numbers or really small numbers, right? Okay, so what I have, the rule of thumb is, and this is the standard form of scientific notation, you start with the first significant digit, so one digit. Okay. You start with one digit. We're not going to get into all that because, okay, you do one digit, the very first digit. You do a decimal, and then everything else that follows. Everything else. You do times 10, and then you have this exponent up here. Okay? And all that exponent does is it tells you how many times to move the decimal, right? If it's positive, positive means right, because that's a really big number, and negative is left because it's a really small number. And we add zeros to hold the place, right? Do I need to go over any of that? I mean, y'all, I'm pretty sure y'all are pretty familiar with that.
Yeah, we're good.
Anything else? At all?
So like if it's 546 million, it would be 5.46. But you don't include the zeros. Times 10 to the,
Okay, so
however.
that's a time. It
Yeah,
was just
right.
confused.
Yeah, that's a time. So, I'll give you a second. Let me give you an example. 2.32 times 10 to the 5th. Okay? So this is a big number, right? It would be, I'd move it over, it'd be 2, 3, 2, that's 2, 3, 4, 5. It would actually be 232,000, right? No, move the decimal to the right 5 times. But what I want you to take away from this is not so much what it represents, but one number, one digit I mean, a decimal and everything else, okay? That's standard form. You wouldn't put 23.2 times 10 to the 4th because scientific notation is just that one digit, okay? So understand this is a multiplication problem, do we all agree? So what if I asked you to take this number this is fun.
That's easy.
And multiply it to this.
You add the exponent.
Good job. It's a property of exponent kind of problem.
Oh, yeah.
This is a multiply problem. This is a multiply problem. This is a multiply problem. Multiplication is, what's the word that starts with a C?
Commutative.
Commutative, which means that I can do it in any order. So I'm going to multiply the numbers in front.
60. Wait, no, in
You
front.
are not.
Why how did you get that?
12 times 5.
It's a,
And then I'm going to do the tens. Because, yes, whoever said that, I can add these exponents here, okay? That is. So what is 2.32 times 1.67? 3.874 times 10. I had just multiplied two numbers in scientific notation. Now, what if?
your if scared me. If. If.
Why might I do this? Let's see.
Adam.
What has changed?
Everything.
Everything has changed. What is 2.32 times 9.67?
19 something.
That's the problem. What is it? Somebody doing it in calculator. Tell me what it is. Calculator. You're exactly right.
Oh, so you move it.
22.434.
Now, the problem that you all have recognized is there are two digits, not one. Times 10. Now, here's where it gets confusing. I need to move the decimal to the left, but I'm already in scientific notation. So I'm going to have to add how many places if I'm moving left because I'm adjusting. I'm already in science. I'm not going from scientific to standard, to regular number. I'm going still in scientific, okay? So if I need to adjust, okay? If I need to adjust left, I add. If I need to adjust right, I subtract. My pen just didn't pick up.
Wait, but when you
Okay.
just move the decimal to the right position.
What? Well, but I want to keep it in scientific notation. If I start in scientific notation, I want to end in scientific notation. So I need to move it left one time. So it's 2.2434 times 10 to the 18.
That is.
Is it?
I'm confused.
But
Okay, where'd I lose you?
But like on the first one when it was 2.32 times 10 to the 5th, you just moved the decimal like 5 times.
That was whenever I was writing a normal number, not whenever I was changing form. Go ahead.
So however many times you have to go to the left and to the right, that's what.
That's how many you add or
Or
subtract.
add or take from the.
Yeah.
Now you know which one you have to do.
It one digit, just one digit. So which way do I have to move so that there's only one number in front of the decimal? Left, one time.
No. No.
Let's do division one. Come on, y'all. Be happy a little bit.
Oh, I'm very excited to you.
Thank you, Donovan. Y'all got that?
I don't know what point after this. I want to try to
Wait, I had to get
make
back.
a real one in my head.
I'm sorry. I'm going back. Yes. Whoever said that. Good? 1.1 times 10 to the negative 3 divided by 5.5 times 10 to the negative 8. Again from your homework, but I won't tell you which one. What can I do? Subtraction part. Let me ask you this. Do you agree that this is the same thing? Can I split a fraction up like that? Sure I can. What is 1.1 divided by 5.5? 11 over 55, which is 1 over 5, which is 0.2. Whenever I have this, and a lot of you said go ahead and move the negative, and you can if you want to, or you can subtract. Negative exponents are okay in scientific notation. What is negative 3 minus negative 8? Negative 3 minus negative 8. Okay. Now, had you moved them and made them positive and then subtracted, you would be back at the same thing. Ah! I got them mixed up. If you move the negatives, this is a 3. Excuse me. Right.
Negative 3 plus 8 whenever you add the. Wait, you lost me. Whenever you. Okay,
You
so
can
negatives go away.
okay, so you can subtract them as they sit, or you can move the negatives and make them positive.
Because the
Either
negative
way,
is positive.
right, either way, once you subtract and simplify, you're gonna end up with 10 to the 5th. Okay, either way you do it. What is negative 3 minus negative 8?
5.
And change. If I flipped them and made them positive, so 10 to the 8 over 10 to the 3rd, what is 8 minus 3? 5. You come back to the same thing. Either way you do it.
Minus the negatives and the minus, I just put it together.
Yeah, it does. You're correct. All right, am I done? Why? Isn't something in front of the decimal I need to adjust? I need to move it which way? Right. So, yep. It's opposite of what you think, okay? When you're expanding a number in scientific notation, positive means move to the right. When I'm adjusting, moving to the right means subtracting, okay? So, it needs to be 10 to the 4th. That's it.
So we don't have to work it out.